So good morning everyone. This is lecture number 11, and in this particular lecture we are going to wind up this chapter as it is. So we'll be finishing up this chapter. We'll be doing problems. We'll be looking at some units and all, and we'll be doing some previous year problems. So you will get a notion of what type of questions you can expect in the examination hall. Now, just to give you a quick recap of what we had done, we were discussing the limitations of dimensional analysis. We have seen that different limitations. First limitation is that two physical quantities can have the same dimension. So just looking at the dimension, you cannot see which physical quantity are you talking about. Secondly, we have seen that numbers do not have any dimension, so dimension analysis cannot be used to predict numbers. So in any formula, if there is a number, we cannot predict that number. Similarly, if there is a sine, cosine, log or exponential function in that formula or in that physical quantity, we just cannot derive it. Also, we have seen that dimension analysis can only be used when a physical quantity only depends on multiplication, division, or power function. If again there is an addition or subtraction coming in that formula or that equation, we will not be able to derive that formula using dimension analysis. The fifth one was in mechanics, we can only have three equations. So if a quantity depends on four quantities in mechanics, we will not be able to use dimensional analysis to find it out. Do we all remember this? Do we all understand this? Can I have quick raise hands that we understand this, sir? Okay. As I told you, there are one or two small points remaining here. So we will first write those points. We will solve one or two questions. Remember, they are not going to ask you a straight question on this. Tell me the limitation of a dimension analysis. That is not the way question would be framed in the examination hall. In the examination hall, question would be put in a different way. And you will have to then understand what the question is asking and what are you supposed to do. Do we understand this? The question would not be straight. Question would be asked in a different way. We will have to understand what is being asked in the question and how does it relate to. Trust me, there is nothing in this chapter that I have not taught you. So no question can come which you don't know how to do it. The only thing is you have to remember what we have done and you will have to apply it in the correct way. Do we understand this? Okay, that was limitation number 5. Limitation number 6 is what we are going to start today's class with. There are only two small limitations remaining. Now, we have seen in the last limitation that if a quantity depends on more than 3, we will not be able to use dimension analysis. Now, there can be a case where a physical quantity depends on only 3, but 2 of them have same dimension. So, if a physical quantity depends on 2 quantities that are having same dimension, then also dimensional analysis is not useful to derive the formula for that physical quantity. So you can have a physical quantity which depends on only three quantities, but two of them are having same dimension. Remember?
Sir,
Yes, beta.
can you hear me?
Can you?
Hear us?
Yes, beta. I can hear you. Yes.
Okay, sir.
Any doubt? Any problem? Shall I go ahead? Do you have any doubt, beta?
No, sir.
Okay. So what I'm going to say here is there can be a case where one physical quantity depends on two or three quantities, but two of them are same. The example is the frequency of a tuning fork. Now the frequency of a tuning fork is given by this formula. Now here D and L, you can see D distance, L also distance. They have the same dimensions. Distance and length have the same dimension. Since these quantities have the same dimension, we cannot use dimension analysis to derive this formula. We can check this formula whether it is correct or not. Maybe correct, maybe wrong, whatever. But we cannot derive this formula because it depends on two quantities which are having same dimension. Do we understand this? Since they are having same dimension, we will not be able to derive this formula from dimensional analysis. Is it clear? Then the last limitation is dimension analysis gives no idea if the physical quantity is scalar or it is vector. Looking at the dimension, you cannot say, well, this quantity is going to be scalar and this quantity is going to be vector, and there are many examples for this. Just looking at the dimension, you cannot say which quantity is a scalar quantity and which quantity is a vector quantity. And the best example that you know, if you look at speed, what will be the dimension of speed, my dear friends? What is the dimension of speed? What is the dimension of speed, beta?
LT minus 1.
LT minus 1. What is the dimension of velocity, my dear friends?
LT minus 1.
See, they are having same dimension, but definitely they are different quantities. Speed is different, velocity is different. One is a scalar, other one is a vector. Dimension, just looking at the dimension, if I just look at the dimension, my dear friends, the dimension of speed or the dimension of velocity, I color it yellow, I color it green. Just looking at the dimension, I cannot say whether the quantity is scalar or whether the quantity is vector. Do we understand this? This is as simple as it gets. So I have told you all the possible limitations of dimension analysis, and with this we come to an end of this particular thing, dimensions. I will just take 5-10 more minutes to cover something known as units, some prefixes, and some common used units. I'll give you time. Once we do this question, I'll give you time to go through this entire dimension. And if you have any problems, you can ask me. Now, remember, as I said, what did I say? I said that these limitations are not going to come as straightforward question. Tell me limitation number 5, tell me limitation number 7. They are not going to come as direct question. Then how are they going to come? They are going to come as indirect questions. And one of those questions, I think, was in one of the tests that you gave. Yes or no? And then I told you, okay, you cannot do this, but you had to apply some common sense to do it. Anyways, now we have covered the chapter and now I'm going to give you this question. Now tell me what is the answer for this one. This has come in your previous year needs. And the question goes like this. The method of dimension analysis can be used to derive which of the following relations. Out of these three relations, the fourth one is none of these. Out of these three relations, dimension analysis can be used to derive which relation? Remember, questions never come directly, beta. They will ask you something in a different way and then you will have to apply what you have read. So which of the equation can be derived using dimensional analysis? Tell me, can you derive equation number 1? Can you derive equation A? Can you derive equation number A? It's a yes or a no. Can you derive equation A using dimension analysis? Is the mic working, beta? Can you derive equation A using dimension analysis?
No, sir.
Why? Why can't we derive equation A using dimension analysis? What is the reason?
N is a number, sir.
N is not a number, my dear friend. E raised to the power minus lambda t. This thing is a number and we cannot derive this thing using dimensional analysis. So, option A is not possible. What do you think about option B? What do you think about option B? Can you derive option B using dimension analysis? Can we derive option B, equation B using dimension analysis? And the answer is no, we cannot derive it. Why we cannot derive it? Because it has this factor, sign of something, which is a number. We cannot derive this as well. Then the question comes, can we derive option C using dimension analysis? And the answer is no, we also cannot derive option C. There are two reasons for this. Firstly, it has numbers, half and half. Numbers are present. You cannot derive numbers. Then we have this plus sign present. So there are two reasons why we cannot derive this equation using dimension analysis. Numbers are present and a plus sign is present. The only option that is correct is none of the above, and that is the correct answer. We cannot derive any of the equations using dimensional analysis, and this is how we use what we have learned. Do we understand this? Okay. Now, this is how you apply what you have learned. Now, I will give you 5 minutes to go through everything that we have done till now so far. Give you 2 minutes and go through this, and then I will take 5 minutes. Just tell you something about common units and common prefixes, which you will have to remember. and then we can go on and solve all the questions together. So I'll give you 2 minutes. Go through this entire thing that we have done. If you have any doubt, please ask. 2 minutes for everyone. Any doubt, you can ask. I'm here. Are you done, beta? We gone through? Shall we continue the class? Anyone has any doubts? Shall I continue the class then?
Yes, sir.
Okay, then comes this table, and you will have to remember these prefixes because they are going to come not as questions. No one is going to ask you what is the meaning of 10 raised to the power 6, but they will be coming in questions, and then you have to understand. They will not even write 10 raised to the power 6. Instead of 10 raised to the power 6, they will write megawatt, and then you will, oh, what is mega? For that, this is the table of prefixes. 10 raised to the power 1 is known as Gika. Do you know this? Yes or no? You'll have to write down the entire table. DA. If you have this table already, not a problem. 10 raised to the power 1 is known as Gika or DA. 10 raised to the power 2 hecto or H. 10 raised to the power 3 kilo or K. 10 raised to the power 6 mega or capital M. 10 raised to the power 9 giga. G. 10 raised to the power 12 tera. 10 raised to the power 15 peta. 10 raised to the power 18 exa or capital E. These are higher powers of 10 when you have more than, let us say, meter. 1 meter. Then 10 raised to the power 1 meter becomes decameter. 10 raised to the power 2 meter becomes hectometer. 10 raised to the power 3 meters becomes kilometer. 10 raised to the power 6 meter becomes megameter. Do we understand this? So that is how you increase the value of the unit. On the left hand side, you increase the unit. On the right hand side, you decrease, which is I am going to plot by the pink color. 10 raised to the power minus 1 decimeter. 10 raised to the power minus 2 centimeter. 10 raised to the power minus 3 millimeter mm. 10 to the power minus 6 micro, 10 to the power minus 9 nano, 10 to the power minus 12 pico, 10 to the power minus 15 femto, 10 raised to the power minus 18 auto. Remember, on the right hand side, when the unit is decreased, everything is a small letter. On the left hand side, some are capital letters and some are small. You'll have to remember these symbols, and you will have to remember, because they are not going to write 10 to the power minus 1. They might simply write deci or milli or micro or hecto or whatever. So you will have to remember this. I'll give you 2 minutes to write down this table. Do you know this table? Well, if you know it, well done. But still, not all of you may know it. So I will give you time to note it down so that everyone gets a fair chance. Everyone must get a fair chance. Shall I move ahead in life? Noted it down. Okay. Take your time. We have some time to spare. You'll have to remember this because they are going to come in the exam. Not as what is 10 to the power 18? You will write exa. No. They will say 1 gigawatt. Then you have to understand. They will not even say 1 gigawatt. They will say just 1 GW. And you are done. What is G? What is W? W is what? G is giga. That is where you use it. Most of you must know this. Note it down. Shall I move forward? No, still noting down. Okay. Let me know when you are done. Shall I move ahead now?
Completed, sir.
Okay. Then this is just how they are going to use and in what way they are going to come. Some terms would be coming in 11th standard, some terms would be coming in 12th standard, and some term would be coming throughout your life. You don't have to write it, just see where they are used. Megawatt 10 raised to the power 6 watt, centimeter, you will come centimeter 10 raised to the power minus 2 meter, kilometer 10 raised to the power 3, millivolt, it will come in the chapter of electric current or electrostatics, 10 raised to the power minus 3 volt. Kilowatt hour, it will come in the chapter of work per energy. Kilowatt hour is the unit of energy. Microampere, it will come in a current electricity 10 raised to the power minus 6. Armstrong unit, that will come in modern physics or in chemistry 10 raised to the power minus 10. You know Armstrong unit, yes or no? That will come in chemistry probably, more likely rather than physics. Anyways, nanoseconds, very less time. It will again come in wave optics and all those places where the time is very less. Picofarad, it will come in capacitance 10 raised to the power minus 12. Microseconds, gigahertz, hertz, and frequency will come in the chapter of waves. And micron 10 raised to the power minus 6 meter. These are the terms, and this is how they will come. You don't have to note this down. It was just to tell you how these go terms are going to come. Okay. Now we have seen the SI units. We have seen the prefixes, but sometimes beta what happens is these units that we are using, the units of the SI unit of length is meter. Now you can understand that meter has got, we know probably this much is 1 meter. Now sometimes this meter is a very big unit to measure something very small, and sometimes this meter is very small unit if you want to measure something very large. Now, can you give an example of measuring something very small and measuring something very large in terms of distances? Can you give an example of measuring something very small or measuring something very large in terms of distances? Yes, my dear friends. Well, measuring something very small is like measuring the wavelength of light, the distances inside an atom, how big is your atom, what is the atomic radius. All these things are very, very small. To use meter, we will have to raise meter to 10 raised to the power minus 12, minus 10, minus 9, and so on. It does not look very nice. Similarly, if we talk about distances in space, in galaxy, to write them in terms of meter is not a very good idea, because then meter will be raised to the power of 20, 26, and 30 and 50. That just looks awkward. And that is why we have some special units or commonly used units which we use if we have to measure something very large or very small and so on. So right now these units have come in your NEET exam, and that is why we are doing this. Some commonly used units of length, and you must remember this and note this down. Some commonly used units of length. The first unit is 1 Fermi meter, 10 raised to the power minus 15. That comes when you talk about the size of an atom and all these small things. 1 X-ray unit, not very commonly used, but it is also a very small unit. 1 Armstrong unit, again it comes in measuring the wavelength of light. It will come a lot many times in your modern physics. So remember, 1 Armstrong unit is 10 raised to the power minus 8 meter. 1 micron, again a small unit of meter that is used in modern physics and all these places. 1 astronomical unit, a very important unit, 1 AU. This is the distance between sun and earth. That is known as 1 astronomical unit, and this is approximately equal to 1.5 into 10 raised to the power 11 meters. You must remember this because they can ask you straight away. 1 light year. Now it may look like year, it may look like unit of time, but it is not a unit of time. It is a unit of distance. This is the distance traveled by light in 1 year. Do we know this? You will have to remember this. Then this very important unit, parsec, that's come in NEET many times. Again, this is a unit of length, and 1 parsec is equal to 3.26 light year. You will have to remember all this because they can come as direct questions in your exam. How many of this unit do you know? Okay, you might not have heard about this. Please note this down. I'll give you 2 minutes to do it. Have you noted down, beta? Okay. Simple things. They might come as straight away question. Then these are the some common units of mass that we use. Out of this, Chandrasekhar unit, we hardly use it, so you may not know it. But you remember, Chandrasekhar unit is a unit of mass. Metric tons, we use this. 10,000 kgs is, oh sorry, 1,000 kgs is your metric ton. You must be knowing this. 1 quintal, we have used this 100 kg. AMU, 1 AMU. When we talk about mass of an atom, mass of neutron, mass of electron, they are very small. We can't write them in terms of kg, because when you write when we write in terms of kg, it is 10 raised to the power of minus 27. It is very small. So therefore we use this atomic mass unit. So these are some commonly used units of mass. Chandrasekhar unit is 1.4 times the mass of sun, so it's a very big unit. 1 AMU is a very small unit, because to measure the mass of an atom or a neutron or an electron, kg, you can't put a kg ka vajan on that side and put an electron on that side. That will not look good, and that is why we have got these units. Out of this, what I think is important for you is AMU and knowing how much, what is Chandrasekhar unit. They might not ask you the value of Chandrasekhar unit. They might just put some points and ask which of the following is not a unit of mass. So this is a knowledge based question, and these are the questions that can come in your exam. So I'll give you a minute to note them down. Now remember, what we are doing here is specifically for your NEET exam. They don't ask these things in a JEE. These things are not asked in a JEE. This is basically for your NEET. Once you are done, please let me know. Have you noted it down, my dear friends? Okay, then a last look at some units of time. Again, this may not be so important. You know how much is 1 year. The time Earth takes to move around Sun, 365 days. Lunar month, time that the Moon takes to complete one revolution, 27.3 days. One solar day is the time taken by Earth to complete one rotation with respect to Sun. So just remember, solar day is the time taken by Earth to rotate one rotation with respect to Sun. One solar year, पूरा revolution वाला time is 365.25. 1 divided by 365.25 is your one solar day. You know this, right? This is nothing new. You must be knowing this. Yes or no? Shall we move on ahead in life and solve some questions? Yes or no? No, yes. Are you noting it down, beta? Shall we move on to questions? No? You're still noting it down? You just have to note one solar day. Don't have to remember these values. I mean, one solar day is 1 by 365 of solar year. You know this. Shall we move on? Don't have to note everything down, beta. You can just write it in your language. Don't have to note down everything. Just write in short. Year, you know what is year? One revolution of Earth around Sun. One solar year. There's no point of noting down everything word by word. You know this. Don't you know this? Lunar day, lunar month. Just write lunar month. 273, 27.3 days. That's it. Don't have to note everything point by point. That is not the point. No one is going to ask you the definition point by point, beta. Chalo, we'll move on to the next point. Shall we? Just have to note in short, beta. Just in very short. No one is going to ask you, okay, the question that is coming in needs it. Give me the definition of one lunar day. That is not they are going to ask you. Just have to write in short. Okay? Got it? Shall I move on? Great. Now, don't have to note down the question. I will send you a sheet which has this entire question probably by today. I will be sending out this sheet so you can attempt this question at home. This is from your AIPMT. I mean, NEET was known as AIPMT. Do you know this? It was known as AIPMT? Yes or no? Which pair does not have equal dimensions? What is the correct answer? You might have done this question before. Which pair does not have equal dimension? So all there are two types of questions they are asked. One is a positive question where they ask you which is correct. Then they ask you which is not correct. So here it is which does not have same dimension. So there is one thing which does not have same dimension. Now the problem here is there might be terms that are coming in this question that you don't know. So let us only look at those terms which we know. Okay, and the rest of the terms when we know we will get to know about them. Energy and torque, are they having the same dimension? Yes or no? Yes, they are having the same dimension. So that is not the correct option here. Look at force and impulse, option B.
No.
They have the same dimension. So that is not the correct answer. They have the same dimension. Now, the other two terms we are not sure about. So let us leave this question here. When we get to know about this angular momentum and Planck's constant and modulus and pressure we already know that, but we may not know elastic modulus. So once we are done with this, then we will come to this. Do we understand this? How questions are done? Questions are pretty simple. Now, let me give you a question which you will be able to do because we have already done similar questions. And this is the question. And I guess in this question, you may be knowing all the terms that are appearing. So can you tell me which is the correct option here? You don't have to note down the question, just have to solve it and tell me the velocity v of a particle at time t is given by some formula. At upon b, At plus b upon t plus c, where a, b and c are dimensional constants. What are the dimensions of a and b and c? This is okay. You can speak up, so you can say a, b, c, or d, whatever. Which option is correct? Yes, my dear friends. Don't have to write down the question. There is no point of writing down the question. Don't waste your time in writing down the question. You just look at the question and give me the answer. Which is the correct option, my dear friends? Velocity v is given by this formula. Yes, my dear friends. You don't have to solve everything. You can just say the answer by looking at the options. You just need to look at this term t plus c. T is added with c. When can you add t with c? When can two quantities be added? Do you remember this beta? When can two quantities be added? When can two quantities be added? When they have the same dimension. That means c and t would have the same dimension. T is time, so c has to be time. Look for the option where c is given the dimension of time, and the correct option is You don't have to do any further. You can just look at the dimension of C and give me the answer. C should have dimension of time because C can only be added with time. I mean, two things of the same dimension, two quantities of the same dimension can only be added. T is added with C. T can be added with C only when T and C have the same dimension. So C has the dimension of T, which is the correct option, dear. Please open your eyes and see and tell me the correct option. And yes, the correct option is A. T is time. C has a dimension of time. In this option, C has a dimension of time. And therefore, this is the correct option. Did we get this? Yes or no? If you get the answer, please let me know so that I understand that we are getting somewhere. Okay? So I hope you will let me know. Comes the next question, and I hope you can do this very fast and tell me the answer very fast. And here comes the next question. It is a straightforward question. We call such questions as a question based on knowledge. Either you know it or you don't know it, just like biology. You know it, you can tick it and move forward. And again, this is a question from AIMS of 2005. Parsec is a unit of time, distance, frequency.
B. Distance.
B.
That is correct. And you can see these are the type of questions that come in your in your NEET ka exam. These are very simple questions. Remember, the only problem we are facing right now is the question that have come in previous year. They also consist of terms that we have not learned up till now, because those terms are going to come in your 12th standard. So to find questions which we have completely solved or we completely know about are difficult, and that is why the questions are limited. So whatever questions we have solved, then this is the next question. If the dimension of a physical quantity are given by m raised to the power a, l raised to the power b, and t raised to the power c, then the physical quantity would be, four options are there. Tell me which is the correct option. Yes, my dear friends.
B, sir.
And the answer is B, sir. It will be pressure if A is 1, m raised to the power 1, L raised to the power minus 1, and T raised to the power of minus 2. Remember, these are the type of questions that are asked in your NEET ka exam, and you may find the same question appearing in your paper as well. And that is why you need practice. You need to do as many questions as they are possible. Can I move on to the next one, my dear friends? Do we all understand this? Remember, the questions that we may have done in the class may be a bit too much compared to the level of NEET, but that was my job. These are the type of questions that you expect in a NEET. The time dependence of a physical quantity P is given by P is equal to P naught exp means e raised to the power minus alpha t square, where alpha is constant and t is time. What is the constant alpha ka dimension? It is a very simple question. And I hope you can tell me the answer, my dear friends. Yes, my dear friends. What is the dimension of alpha? Remember this thing that you see in yellow. If I look at this, if I write this correctly, it will be written as P is equal to P naught e raised to the power minus alpha into t square. So what you see in yellow is e raised to the power of something. Now, if it is e raised to the power of something, this something has to be what? This something has to be a number. Therefore, the dimension of alpha into t square should be dimensionless. So the dimension of alpha would be how much, my dear friends? It will be the reverse of the dimension of t square. So dimension of alpha will become t raised to the power of minus 2. Yes or no? Why is taking so long? It should not have taken so long. And the correct answer is option B. Yes or no? No or yes? Well done. Since time is getting over, I will finish this class with one last question, and that is why whatever we have done, my dear friends, there has there is a reason behind this. Similar questions have come in your exams, and there is a high probability that same question may come again, because question in NEET, since they are so much, they get repeated over and over year again. We do something for a reason, and I told you the prefixes for this particular reason, because this question has come many times. Which of the following is the smallest unit? Again, a question based on your knowledge, whether you know it or not. If you know it, it's yes. If you don't know, it is gone. Which is the correct option here?
C.
C. And it's a question straight away based on your knowledge. If you know it, it's done. If you don't know it, it's done. So that's it from my side for this particular chapter. We are done with your units and dimension. I would be sharing the sheet with you. You can try the questions. Remember, the question that we might have done may be too difficult for you for them to come in the NEET exam. The question that you see are pretty simple. The only thing that you will face when I send you the sheet and you try the questions is that there may be terms which are coming in the question that we don't know, and therefore you cannot do these questions. Don't worry, I will be covering this chapter again once we know those terms. So at the end of your course, when you know those terms after 12th, I will be doing those questions which we have not done now. Do we understand this? On
Sir.
that,
Thank you very much, sir.
I will wind up today's class. Take care
Rise
and
up the sun.